The atmosphere. Aircraft fly within the Earth's atmosphere. The atmosphere is the gaseous envelope that surrounds the planet. The atmosphere's weather, temperature, and properties all affect aircraft flight. This envelope of air rotates with the Earth but also has a continuous motion relative to the Earth's surface, called circulation. It is created primarily by the large temperature difference between the tropics and polar region, and is complicated by uneven heating of land and water areas by the sun. The Earth's atmosphere is divided into different levels on the basis of temperature. This figure shows how temperature varies with altitude in the atmosphere. The x-axis represents temperature in degrees Celsius and the y-axis represents altitude in kilometer. Note the alternating regions of decreasing and increasing temperature with height. An inversion exists when temperature increases with altitude. These layers are troposphere, stratosphere, mesosphere, thermosphere and exosphere. Between each layer exists a pause, in which the temperature remains constant with height. Since most weather occurs in the troposphere and since most flying is in the troposphere and stratosphere, we restrict our discussions mostly to these two layers. The lowest region of the atmosphere is the troposphere, which begins at the Earth's surface and extends to an altitude of approximately 11 kilometers. Troposphere contains 75% of total atmosphere by weight. Tropo means to turn over, and refers to the fact that air can move up and down in the troposphere. The height of the troposphere varies with latitude and seasons. It slopes from about 25,000 feet over the poles to about 55,000 feet over the equator. The height of the troposphere is higher in summer than in winter. In the troposphere, temperature usually decreases with increasing altitude, about 2 degrees Celsius per 1,000 feet or more exactly 1.98 degrees Celsius per 1,000 feet. Or 6.5 degrees Celsius per 1,000 meter. Troposphere is the lowest layer of atmosphere. The troposphere contains 90% of the water vapor in the atmosphere. The water vapor comes from evaporation of ocean water and then gets mixed throughout the troposphere by up and down air motions. The troposphere is where most of the clouds and weather occurs. Thus, troposphere is the most significant to aviation. At the top of the troposphere is the tropopause, a very thin layer marking the boundary between the troposphere and the next layer above, the stratosphere. Tropopause marks the break point where temperature stops falling. Tropopause starts from 11 kilometers or 36,000 feet up to 20 kilometers or 65,617 feet. Temperature is constant in tropopause, minus 56.5 degrees Celsius. Height of tropopause varies with temperature on Earth's surface. Equator is hot surface where large mixing happens, thus height of tropopause near equator is large. Height of tropopause is highest, 60,000 feet near equator. Temperature of tropopause is lower near equator, minus 75 degrees Celsius. Pole is cold surface where small mixing happens, thus height of tropopause near pole is low. Height of tropopause is lowest, 25,000 feet near pole. Temperature of tropopause is higher near pole, minus 50 degrees Celsius. The tropopause height does not gradually drop from low to high latitudes. Rather, it drops rapidly in the area of the subtropical and polar front jets. There are two locations where the tropopause abruptly changes height or folds. These are at approximately 40 degree and 60 degree latitude. Above the tropopause is the stratosphere. The stratosphere contains a type of oxygen called ozone that absorbs sunlight, resulting in temperatures similar to those found near the Earth's surface. The ozone layer absorbs harmful solar ultraviolet radiation and protects the Earth. Stratosphere extends from 11 to 50 km at mid-latitudes. The temperature in the stratosphere rises with altitude. Temperature at the beginning of stratosphere at 11 km is minus 56.55 degrees Celsius. Temperature reaches 0 degrees Celsius at stratopause at 50 km. Flying in the stratosphere is generally smooth with excellent visibility. The air is thin. Stratosphere contains about 1% of atmosphere's water vapor and offers very little resistance to the aircraft. The general lack of weather in this layer makes for outstanding flying.
you